With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, a block of mass m and a cylindrical tank which contained water having small hole at the bottom which is closed initially and are attached to other end of the string which passes over a light pulley. At t equals to 0 the hole is opened such that the water start coming out of the hole at a rate of mu is equals mu kg per second and the velocity is v relative to the cylinder, right? This is the relative velocity. Now acceleration of the blocks at any time t will be. So this mass with which it is coming out is constant with time. So if you see at any time the mass of this cylinder will be, I will write down, it is m minus mu t. Since in t time this mu t will get out of the cylinder, right? So this will be the mass of this. Now the acceleration of the system, if I talk about, it will have a downward acceleration a and it will have a upward acceleration a, right? And the tension on the two will act in upward direction t and t, t and t, and mg will in downward direction. And this is the tension. Apart from this cylindrical body will also experience a thrust force, right? And if I write down the thrust force, we know that it is the rate of change of mass into the relative velocity. Equals to mass per unit time is mu and v relative is v, right? So this is the thrust force that is experienced by this cylindrical body. Now if you draw the forces on the two, so the only two forces which is acting on the block is mg and the tension, and apart from this cylindrical body is also experiencing a thrust force, right? And the magnitude of thrust force, you can see it is this, right? And if you see, the thrust force will be in a direction of, it will be in a direction this, because if you see here this cylindrical body and this particle which is coming out, the water particle, so the water particle is certainly getting the momentum in downward direction, right? That is dm into the ve. So certainly on this the thrust force is in downward direction, so the thrust force on this cylindrical body, that is the reaction force of this thrust force that is acting on the water particle, it should be in upward direction. So I will write down this. It will be, so if you see the acceleration is a in downward direction, a in upward direction. So I will write down the force equation as T plus Ft minus the mass at any time t into g is equals to mass at any time t into a. And the same force equation I will write down for this. It is moving in downward direction, so it will be like this. So just add the two. So t will get cancelled out if you add the two, right? So I will write down thrust force plus mg minus mtg is equals to mass plus mass of the cylinder at any time t into the acceleration. Now you can just put the value of thrust force, it is mu times of ve, and the mass at any time t, it is m minus this. So I will write down ve plus the mass this, here g will also be there. So if you open this, right, this minus this, this m will get cancelled out, right? So mu into v relative, this mg will get cancelled out and I will write down plus mu t into g, right? So is equals to, if you add these two, right, so m minus mu t into a. Now I will write down the final expression a is equals to, if you see, if I take this mu outside, it is ve plus in division 2m minus mu t. Now you can check for the option. So if you see, A is the correct option. Mu into VE plus GT in division 2m minus mu t. Simple. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.